Hello and welcome. So, find the value of x. And we're given double triangles here. Alright, so the first most important thing when we're looking at double triangles like this is you're like, oh, well, okay. What kind of triangles do you have? Right? We're going to start out with what we are looking at inside of our diagram here. I'd recommend just starting with this bottom triangle. Okay, what do we know about that triangle? Well, we see two of these dashed lines. What do those mean? That means that the triangle sides are, those sides of the triangle are congruent to each other. Meaning that if that side was 20, this side would be guaranteed to be 20. They would have to be equal because we're told that they are equal. Okay? And you're like, great, well, how does congruent sides help me? Because we know something about the angle, not the sides, right? But that does help you because as soon as you know that the two sides are congruent, then you know that this is what's known as an isosceles triangle. Okay, isosceles triangles have a lot of really cool properties. The one that we need to know for this particular problem is that once we know that the two sides are the same, the base angles are also the same. Well, that's nice. What's the base? Well, the base is the third side that is not congruent to the other two. This is your base side. Alright, so that means that your base angles, that little angle in this corner forming the base, and the other angle in the other corner forming the base are the base angles, right? Those are your base angles, and they're guaranteed to be congruent by the property of isosceles triangles. Okay, so that means if this side is 51.5, so is that side. Okay, and you're like, all right, great, well, where do I go from there? Well, use your last property for any triangles. What do you know about any angle, all of the angles in a triangle? They have to add up to 180 degrees. They have to, which means that the 51.5 plus the other 51.5 plus our third mystery angle right there has to be 180 degrees. It has to. That's guaranteed for any triangle in Euclidean geometry. It has to add up. So we know our first blank is 51. Whoops. 50, oh heavens. 51.5. Right there. Boo. Yeah. Okay, so from there, combine your angles, add them up to 180 degrees. So we know 51.5, add those together, we get 103. Plus our third mystery angle is 180. Subtract the 103 over, and that means that that third angle in that triangle down there has to be 77, right? This has to be 77 degrees right there. Okay, that angle 77 degrees. Okay? And you're like, great, well, how does that help me now? Well, keep looking at the information you're told in the diagram. We have this little box there. What does it mean to have a little box in the corner of any diagram? That means that it is a right angle, meaning that that angle is equal to 90 degrees. So if we know that this section of the angle is 77, then this angle has to be the remaining portion for it to add to 90, meaning that 77 plus this little portion right there has to be 90 degrees. So if you subtract 77 over to the other side, then you're going to get that that last remaining portion of the angle is 13 degrees. Right, you'll find that is 13. And then you're like, awesome! Now I found what that angle is. How does that help me solve for x? Well, now you're in the other triangle. What do we know about this triangle? Well, you know you have two congruent sides, so you know it's an isosceles triangle as well. Where is the base? It's the third side that's not congruent to the others, meaning that here's base angle number 1. We already have base angle number 2 highlighted, right? And by properties of isosceles triangle, you know the base angles are the same, which means that 2x plus 7 must be the same as 13. There is the relationship. subtract the 7 over, and then you get 2x equals, ooh, negative 7 just looks pretty bad. Let me rewrite that. Okay, then you just get 13 minus 7, which is 6. Divide by 2, undo that multiplication, we're left with 3 as an x value. You've solved for x. You could double check it, right? 2 times 3 is 6, plus 7, 13, positive number. It does match our other 13 like it should. It's a valid solution and you're good to go, right? But that is how you would solve for this. Just use your properties of isosceles triangles. Once you know you have two congruent sides, find your base angles. Once you know you have two congruent sides, find your base angles, right? It's as crazy as it has to go on a lot of these. Okay? All right. Thank you for watching.